Welcome to Slight Reliability, learning SRE one day at a time. I'm Stephen Townsend. Welcome back to Slight Reliability. I'm Stephen Townsend, and this is the show where we learn about SRE and observability 1 week at a time. Today, we're talking about Tracetest.io, and here to talk about today is Ken Hamric. I hope I said that correctly.
That's correct.
Ken has more than 30 years experience in developing software products with early roles as a developer, DevOps, and a system integrator. He's the founder of two successful SaaS businesses, the most recent being cross-browser-testing.com, which was acquired by SmartBear in 2016. And he stayed on into 2020 as the VP of Engineering over both the combined web and mobile testing platforms as a service. He's now started his third project, Tracetest.io, which is an open source testing tool which relies on open telemetry tracing to enable observability-driven development. So welcome, Ken.
Thanks, Stephen.
I was just curious, just to maybe kick things off, how did Tracetest come about, or when did you see the need to combine distributed tracing and testing?
After I left SmartBear, I took a year's hiatus, which I'd promised myself after developing my last business I would do, and ended up coming back to work with people that I'd really respected from SmartBear that had formed a company called CubeShop, and they're a tech incubator in the Kubernetes space. So I was brought in to start a project. I'd started a couple of startups before, so I was asked to pick a project, come up with the idea, and hire a team and start the project. So that's kind of the genesis of looking for an idea. I would originally looked pretty heavily in the Kubernetes space for what I thought was room for a good idea. Every idea I came up with had already been done. Just everything. I would say, hey, we should do this. And Ole, one of the CTO, he's like, hey, have you looked at this product? They've been doing this for about 5 years. Have always been interested in observability, mainly through pain of not having good enough observability, particularly in my previous role. So I started looking at observability. When I saw a trace, I immediately thought, boy, you should be doing testing off this. Came from a testing background at SmartBear. They were one of the leaders in testing across a lot of different products, including the one that they purchased from me. So it was pretty natural once I saw standards-based tracing to transition to there should be tests built upon this data.
When we caught up, it was a couple of weeks ago now, you were mentioning in a previous role, real device testing.
Yes.
And
yes.
It was one of the first situations where you thought, wow, we really need some much better observability in this situation.
I can go through that. So in 2008, we started a company with a couple of guys I worked with previously called cross-browser testing. We started off with just VMwares, so Windows images. And so our main customers were people that were on Macs that needed to test, what was it, IE6 back then, or whatever it was, IE4, I think. So they could get on the system and test it. And then we added Macs, so you could test PCs or Macs. And then in about 2010, we started adding iOS devices. So once you started getting our API surface, you could hit the API surface and we'd tell you, yep, we're going to give you one of these devices. And we'd instantly return a 200 and say, yep, we got your request for this device. And then there's a lot of stages as we provisioned and got the system ready for you on the back end. And even once the path to get to the back end, if it was a VMware system, everything went through this Java thing called Brain. The next step was this a Python program that distributed the requests to the individual platform. And then once it hit the platform, it'd be a different language for each platform. I couldn't write the same code for an iOS device that you write for a Windows VM. The code was different in different languages. So it was great. You'd write it, and trying to troubleshoot it was hard. Your normal test tools would hit the API surface and say 200, but your customer didn't live testing. They never saw the image or the screen of the remote phone that we've got hanging in our closet. So trying to troubleshoot it, we would jump from literally there are times that I'd have a screen up and I would have 12 windows open looking at logs from 12 different systems. So I'd try to identify each of the systems and each of the once we got to the Macs with iPhones, we'd have a Mac and two iPhones plugged into it, another Mac with two iPhones. I'd have to figure out which one it is, get the logs. So we went to the Elk Stack in probably 2000, maybe 15, and started implementing it. And we quickly realized it was nice to have all the logs in one spot, but we still needed a way to see the transaction as it flowed through. So we started putting basically a magic token in every log so that we'd have the request ID. Okay, this customer, this is a request ID for this session. And we'd try to make sure we put that request ID in every single log as it is passed through the system. And it was okay. And it was better than what we had. Distributed tracing, it's a standards-based way to give you a full system trace. When one API call happens, you get every single microservice and every other service that it talks to, and you get consolidated information from it. So
yeah, I mean that's something I've actually never really covered on the podcast before. Is what is distributed tracing? So how would you define what it is, and how is it? Is it just collecting logs and then the way that you work with those, or how is it different from logs?
With logs, we always had trouble with timing. So we'd try to have logs, but by the time they got to the Elk Stack, when we'd actually look at it, you could kind of get a sense of what happened. If you knew the system really well, you might be able to piece together what occurred, but the timing was always a little bit different. With tracing, you get a picture, it's like a waterfall diagram of this is exactly what happened. We called the main API. It called off to this process. That process started at this time and ended at this time. It called three other processes, and you can follow the entire chain down and see exactly what happened. So it reduces, just from a mental complexity. It was great to start Tracetest in 2008. And originally I'd written a lot of the code, but we'd hired new people in, and they had to try to get a grip on the path of these transactions through systems. And it was really hard to visualize, hard to see. Well, Trace is super visual. So it shows you this is exactly what happened with this one transaction. So you fire off a transaction and it builds a trace, and you can see this is the exact steps it went through. And with each of these steps, here are some key metrics that you've recorded, like the, here's a SQL query that was issued at this time. And you can see, okay, we did the SQL query and we got it back within 100 milliseconds. So you get a ton of information.
There's two common themes which keep coming up on the show. One of them is around cognitive load for SREs or any sort of senior engineer, especially, it seems to get more and more complicated over time. And the second is the technical complexity of the systems we work in and being able to understand what's happening. And it sounds like distributed tracing is maybe not the single, like the panacea, but it goes a long way to help make life easier in that context. Would that be fair?
I think so. If you look back, when I started, that was the last semester to do punch cards in college. So that was a long time ago. But quickly, when I started writing code, you'd have a log. And you're starting off, I was writing applications that were single user, single threaded. So I was pretty much guaranteed the order of the log was going to represent what happened. And then you started getting distributed systems, and that's where, it passes from one system to another, and solutions like the Elk Stack came in, and they helped you visualize the logs across all those services. But it gets pretty complicated with a lot of people and multiple people using the service, lots of requests coming through. It's just hard to see. And traces, provide, it's one of the three tenets of observability, and there's a reason they label it under observability. It helps you to see what's happening.
I can see that distributed traces provide like two very obvious benefits to me. The first one is that they help you understand the behavior of a complex system in a nice visual, clear way. You can see what's happening with a particular interaction or transaction across a solution. And the second thing is I'm assuming it helps you investigate and remediate incidents or issues or weird behaviors much faster as well. Are there any other sort of use cases or benefits or things which are not so obvious?
In a large organization, we only had, when we sold, we were 13 people, and we got up to about 30 people. But we still had things of, it's not the API, it's the Mac. We didn't know where in the system this transaction was failing. So it's pretty easy when you look at a trace. You could see this one got returned 200, 200, 200. This one returned to error. Okay, I know not who to blame necessarily, but who to at least talk to and say, hey, we're seeing this problem and we need to fix it. So much quicker to repair, I think, is a key value of it. Much easier to train people. This is what the whole solution. I think without distributed tracing, if you want to figure out how the code works, you have to look at the code. And so if, multiple teams writing multiple repos, how do you look at all this? You try to rely on documentation that was written at a point in time and almost immediately got old. A trace is going to show you what actually happened. And that's a lot of benefit to it. So
that's a really interesting point. Yeah, documentation immediately goes out of date. You don't necessarily have access to all the code, but if distributed tracing is set up, I guess, the right way, then whatever you change and do, it's going to adapt to that and show you what's actually happening. So sort of it gets kept up to date in a way, which I like the idea of that.
Yes, I'm trying to think of other benefits. Timing is always good, so it looks like a Gantt chart. All the tracing systems look like a Gantt chart. So they really show you, what the total call time was for each one of the microservices, for each of the database calls. It really breaks down how long things take. So it's very helpful in determining if something starts going slow. You can quickly see, what's going slow.
I remember a few years ago when I was still a mostly performance testing, one of my colleagues, she wrote a Node.js app because we didn't really know about distributed tracing tools at that time, although they were available. We just didn't know they were there. So we were consuming logs, and they did have a trace ID, and she was rendering her own Gantt charts.
It's shocking how common that pattern is of putting an ID through the things.
Yeah, I was just saying, well, she basically redeveloped her own, I don't know, Jaeger or Honeycomb or whatever, just using logs, which isn't the same, but we were trying to achieve what distributed tracing was achieving, and I wish that I'd known about it then because it could have made life easier.
And I'm in the same boat. We did not either, and we basically rolled our own because we needed it. We were struggling without it, and we needed the visibility, and it was better, but Elk with Magic ID in it is not the same thing as a trace. Trace is much easier to visualize, much easier to look at. You can, the timing information isn't there. When you have this consolidated log, you have to manually start looking at timing and try to figure it out. It's a lot more load on your brain than a trace is.
I'm curious, just thinking right now, what benefit do logs have over distributed traces?
I think maybe possibly in developing, you could say it's easy to write a log. It's super easy to write a log, and they're very low tech. So I'd say, for tracing, you do have a little bit more infrastructure need. There's a little bit more, if you're doing manual instrumentation, there's a little bit more boilerplate code to add in than a log.
I suppose distributed traces are a bit like extracting out the events, that the kind of things you put in an access log, but then logs themselves, you can have all kinds of logs which can have a lot more verbose information. I kind of completely missed that point.
Yeah, but they definitely, I don't think it's a either or. I think both things are needed and useful, and that's with the Open Telemetry project. They are trying to consolidate the way that you gather observability data, and the things they're focused on are traces, logs, and then metrics. And there's a place for all three, and they each serve their own purpose.
So distributed tracing, we've kind of had a little discussion about what that is. Using it as part of testing isn't something that I would have naturally thought of. I would think anything around observability is about production. That's what you do when you're observing production. So how does distributed tracing help in the world of testing?
So for unit tests, it has a place, but it's not important. Once you start connecting systems together, the traditional ways have been, you can try to mock the outside system and rely on your mock being accurate and just test your local code. And there's benefits and there's downsides to that. One, the mock may not work like you expect it to. So there always comes a time where you're doing some type of system or integration or end-to-end test to really make sure the system is functioning like you need it to. When you start doing that, you typically write a ton of boilerplate code and a little bitty assertion. You write all this stuff. All right, I need to get a connection to that database. I need to do this, and I need to handle credentials. And then I'm going to ask the database something, get something back. And then I'm going to say, was that what I expected? With a trace, all that plumbing work and making things observable, because that's really when you're building that infrastructure to say, I need to connect to these things so I can tell what happened, you're trying to provide visibility. Well, tracing provides visibility. If you've already implemented distributed tracing, you've made your code observable or you made your system observable. So trace-based testing just looks at the data coming back from an API call. So let's say you've used Postman before. We do a REST call and we get a response back and we test against that response. So if I was going to name Postman, I probably would have called it response test. So Tracetest is we do a call, we get a response back, and we can test against that also. But we also correlate it with the full system trace. So we have data not only about the initial API service, but we have data about every single microservice under that. The first time we run the test, we do the triggering transaction, we get the trace, and then the system allows you to say, this microservice down here is returning a 200. We better always return a 200. So you click on it and you say, I expect this to return a 200. HTTP status code should be 200. Click. And that's one assertion. And you did that without writing a bunch of stuff together, all this data, because you've already instrumented your code with OpenTelemetry tracing, if that makes sense. You don't implement distributed tracing in a day. It's an effort to put it in. Once you put in distributed tracing, you can get distributed testing with trace-based testing and Tracetest super easy.
I think it sounds super valuable. I can see two situations. One is if there are particular things you know that you want to happen or not happen, like I'm calling this complex, service, which involves a whole bunch of different components talking to each other. I know this component needs to do this thing in order for things to succeed. I can set up an assertion. Great. That's one way that'll help you pinpoint an issue very quickly. And the second thing is just, I guess, during your testing, you just being able to go and look, is the flow through the solution as expected? Is there anything unusual? I've got an anecdote from many years ago, performance testing, looking at essentially an insurance claim platform, but in the context of government for something else. And I noticed somewhere along the way, by looking at some obscure logs from a document management system, that there were 40 or 50 times more documents being stored or retrieved than we expected. And it turned out that they'd added some custom code and that on every single page of every screen on the website and on the application itself, it was just retrieving a bunch of documents for no reason. And if we'd had Tracetest or distributed tracing and testing together at the same time, when that code change was made, immediately you would have seen 40 documents being retrieved.
We did the same thing when we were first starting Tracetest. One of the developers just going to write a test, and he looked at the trace. And when we were bringing back, the list of tests, the 20 tests, it was going to get each one from the database one at a time. And he's like, we got to fix this. So, it's if you can see it, you know what to fix. A lot of times you just can't see it. So
with Tracetest, what's the workflow? Like I'm a tester and I'm completely new to this. How does it work?
Yep. So I'm skip the install process. It takes about 5 minutes to install into Docker or into Kubernetes, open source, all that stuff. So you've got the UI up, you hit new and you tell it new test. And the first thing it says is, okay, how do you want to trigger the test? Do you want to hit a REST API call? Do you want to paste in a curl command? Do you have a Postman collection? Do you want to do a gRPC call? So you have the trigger and you say, yep, and you configure it like you want. If it's a HTTP post, I'm going to do a post against this URL. Here's my body data. And you hit run and it runs the first time. It collects the trace. It shows you both the response and the trace. And then you start saying, okay, this is the known good state for the system. I'm going to start adding in some tests for it. top level call should return if it's a post, a 201. So status code should be 201. Total length for the call should take less than 500 milliseconds. Add that. Then you start looking down the system. Let's say the call puts a message on an async message queue, and you've got an inventory and a accounting and one other system that need to pull that message off. And you know all three better happen. You can set assertions. You can find the particular span or this particular microservice and say, I expect this to exist, or I expect it to exist and return a 200. So you basically can set up the roles of what you expect to see when things are properly functioning. And then at that point is a test. You can download the test. It's a YAML format. You can download the tests. You can save it in GitHub. You can run it as part of your CI/CD process, et cetera. So that's kind of the the workflow of setting it up. A distinction from a normal, and I've worked with a lot of different testing tools, but they're all, you issue a API call and you get back a response, is there's more complexity to the response in a trace. It's not a flat object. So, and this felt like deja vu from my web testing days. We needed selectors. So you've got a trace that is basically a tree, and you need to be able to say, what part of the system am I trying to apply this assertion against? So you'll say, I expect the name of the microservice is this, and maybe if it's a database call, I expect to see, this database name. So you have to have some way to identify what section you want to target. And then you give a list of the test specs. What is it you're going to check for on that particular service or particular span? Which gets interesting because you can do things like, which I think is fairly unique. I've not run into this in testing systems much, but you can say things like, you can make very narrow assertions or very narrow selectors, but you can also make wide ones. You can say, my selector is going to select all MySQL database calls, and I expect the time for the call to be less than 100 milliseconds. So that one assertion or test spec is going to check if you've got 5 database calls in your system, is going to verify all 10 or all 5 are happening less than 100 milliseconds. If somebody changes the code and does another query to another database, it's also going to start checking it. I think that's a cool, pretty cool capability. And there's things like all gRPC systems should return status code 0. Fail the test if they don't. Things like that. So
I like that. So you can kind of do global assertions, or assertions that apply over a large number of things, or ones that just apply in one very specific interaction.
And we've been developing work to make the selectors pretty specific. So you can say, all right, I'm going to identify a span like this, and it's a child of this span. So you can get very specific about your targeting.
I guess if someone wanted to, out there listening, wanted to get involved and have a go at using Tracetest, the first thing they need to do is have distributed tracing in place, which is, like you said, it's no easy task. Any recommendations or hints about, if you're in an organization which doesn't do it at the moment, any advice on how to get things going, or maybe even get buy-in from leadership that this is a good thing to do?
I was at a thing that had a pretty good presentation on that. It was at KubeCon, Monday of KubeCon. I could try to find it and add the notes to it on the buy-in front. Typically, if there's enough pain, I think the buy-in can come fairly quickly. As far as resources, I'd either start with OpenTelemetry.io, which is the open source project to standardize the way that information is collected. In today's day and age, it'd be hard for me to see people going a different approach. All the leading vendors are behind it. All the open source projects are behind it. It really has pretty universal support. So I'd start there, and then I think working with any of the either open source projects that support tracing, or working with any of you may make a choice to use a vendor, any of the vendors. The only thing I would be pretty specific about is I would want to instrument my code with OpenTelemetry based standard instrumentation.
There's a concept that we talked about last time, observability driven development. Can you elaborate? Like, what does that mean? What is observability-driven development?
I'm going to have to not get myself in trouble. We wrote an article and posted it in Reddit, and we said, we didn't say TDD was dead, but we came close. We said it's the past and observability-driven development is the future, and got in trouble. So observability-driven development is baking observability in from the beginning. And I really look at it as a form of TDD. If you're using Tracetest, for example, you would build your test to say, I expect to see this span with this attribute, and it should have this value. And then you would code your app, and you'd build the app, and you would include the observability into it so you can see that attribute in the span. So when you're outputting the trace, you would make sure to include that in, and your development is done when you run your trace test, and it says, yep, I see it, and your test pass. So it's a form of TDD. The difference is it's leveraging your observability data. So instead of building like a framework like we were talking about earlier, where I'm going to go out to the database, I need to do all this plumbing. The plumbing you put in the work you put in is to make your system more observable. And by doing that, when you're in the development process, when you get into a production situation, you have a system that has useful information in it. You didn't haphazardly say, okay, I'll make this observable, this is observable, this is observable. You had specs at the beginning to say, this is what the system needs to do. I need to verify it does it. I'll make sure those things are observable, and I'll write tests against it. I think for distributed systems, it becomes necessary. You don't want to write your code. There's some reason you do test-driven development. You don't want to write your code and then go back and try to add some tests. You don't want to write your code and then go back and try to make it observable. You build it in from the beginning.
Playing devil's advocate here, with test-driven development, I think it's conceptually, I guess for a developer, it makes sense to me. I'm writing something that's going to achieve a thing. Let's build the test to make sure that thing happens or not. With observability, it's much more complex because you might be writing a bit of something which is part of a complex system, and you might not understand the whole system. So I think it's maybe a little bit harder to go in advance. This is the internal behavior that I expect. You know what I mean? It seems a little bit trickier. But I do think, regardless, even if you haven't set immediately what your desired behavior internally is, the fact that you can write the thing and then immediately see what their behavior is equally as valuable to me.
It is. And that's, you were talking about earlier, writing code that you were doing 40 calls against the to bring up PDFs or documents. That would be caught in the development process if you had the observability to see it in your monitor. It's kind of including monitoring. It's not making it just the world of the SREs or the DevOps people to be concerned about observability and monitoring, but bringing your developers into the process, which is always healthy. That's something I've always pushed for, is the developers were very active in the operational phase of the system. We didn't throw it over the fence to the SREs or to another group.
That's the challenge, right? The perpetual challenge is, how do we move this observability space, which is, I'm actually just currently reading Observability Engineering, the book about it. It's beyond a technical discipline. It's a socio-technical issue, really. And the challenge is, how do we make this a thing we don't worry about? It's not just handled by the ops and the SRE after the fact, but involve it from the beginning where we get the most value. And how do we make it engaging and interesting and show the value of it, and then make it easy for developers and testers and people in that delivery space to go, yep, I want to do that, and it's easy for me to do.
It's a good pattern. Charity, just for reading Charity Majors, I think she had the first. It's the first documented use of the term I'd seen, and it's worth looking up. Observability-driven development, and there you go. And read her writing on it, because I think she's got some great viewpoints on it.
So if someone out there wants to start using Tracetest, they can head to tracetest.io. Are there any, outside of their website, are there any resources or things you think people should be aware of to help them get involved and use it?
Yeah. So on the site, there's a link to GitHub, which also has the ability you can download from the tracetest.io or the GitHub repo. We have a Discord channel listed at the top, and that's how one of the methods we use to communicate with people. If you have an idea, You can put it there. You can also go into GitHub and just raise an issue. And like we had a guy from Elastic say, hey, we want to make it so Tracetest natively supports Elastic. And he's helped us over the past couple of weeks get that set up. And we're going to be releasing it this week. So we actively try to emphasize requests from the outside as the work we're doing versus the things that Ken or one of the engineers thinks needs to be done. So I'd say GitHub's good, issues, and then Discord is where we kind of host conversations.
And are you looking for like contributors in the community?
Absolutely. We've been doing work recently to kind of document the process of how to contribute, and we're starting to get contributors. For example, Hamric, who I think you had on last month, he's doing a integration with, I'm gonna blank on the name. It's a testing tool. I won't remember the name. But he wanted to see that tool work with Tracetest, so he set up a little integration, which is awesome. And we're gonna add that to our website as an integration and document. This is where you need to look at to know how to do this. So it's pretty cool to see outside people coming in and helping contribute.
Okay, thank you so much, Ken, for coming on the show. It's been an absolute pleasure. And Tracetest.io and just the whole concept of using distributed tracing and testing is a great idea. And, I fully support it and think we should be doing more of it. So, thank you very much. And
thank you.
So that's all from another episode of Slight Reliability. I'll see you next week. And thank you for subscribing.